my name is Afton Giles, and I'm Sustainability Coordinator for the City of Pittsburgh. I am one of 4 members of the Office of Sustainability. We also have with us today Ari and Rebecca, who are our Resilience Coordinator and our Resilience...
Rebecca's the Resilience Coordinator.
Resilience Analyst, right. The 2 new positions that joined us this year, and we also have Grant Irving, who is our manager, who is the Resilience Manager and the Sustainability Manager as well. We want to thank you for joining us for our 3rd workshop in our Green Workplace series. We will be offering the series once a month through July of next year. And this one today is going to be on stormwater. So we're going to start with PWSA, who's going to help to frame the regional issue of stormwater management control. We're going to follow up with Phipps Conservatory, who's going to tell us a little bit about what they're doing at their living building and how they're managing stormwater on more of a larger commercial scale. And then we have Nancy here with us from PRC, who's going to discuss what you guys can do at home in order to improve your stormwater. So let's get started.
So I'm going to tell you a little bit about the Green Infrastructure Program at PWSA, and along the way talk about stormwater and what it means for the city. So PWSA, as you may know, you may receive a water bill from PWSA, provides drinking water to a large number of Pittsburgh residents, and also maintains the city's sewer pipe network. PWSA is a municipal authority, which means that we are part of the city and yet have our own board that's appointed by the mayor.
Can I interrupt you? Will this be available by online, by link or anything?
I think so.
It will be. We're taping it now, so it'll be available. Thank you.
And feel free to contact me if you have additional questions. And on the PWSA water bills, you'll see also a sewage treatment charge, and that's coming from Alcosan. And we're also invested in infrastructure improvement, which, along with many other cities, Pittsburgh needs. So a few stats on our water production: 70 million gallons a day. With a capacity of 120 million gallons a day. A more significant storage capacity, which means that we're pretty well covered in case of emergencies. Lot of pump stations, a lot of catch basins, a lot of fire hydrants. It's a pretty big system, and it's an old system, and it requires a lot of maintenance. So just to clarify that PWSA is not Alcosan. Sometimes people get confused. But the Allegheny County Sanitary Authority is the wastewater treatment plant in the region and serves 83 communities, including the city. And they discharge the treated sewage into the Ohio River. So there's a coming and going of water for drinking and of returning of treated wastewater to the river all along, and that happens in many rivers. So PWSA is one of Alcosan's customers, and I'd be happy to answer more questions about that. But the next topic is basically why stormwater is an issue for PWSA, because generally PWSA has been known for dealing with things below ground. Once it enters the catch basin, once it's in the sewer pipe, then PWSA deals with it until it gets to Alcosan. But why are we talking so much about stormwater? So we have a lot of rain in this region. When we have rain, we have an overflow of the sewer system. We have got a diagram of that. I'll get to that in a second. So stormwater runoff is basically when we have a surface that's impervious, that's paved. There will be stormwater will have to go over it somehow to get to the catch basin, to get to the sewer system. So this can cause some issues. This can cause flooding. This can cause contamination in our waterways. Occasionally we have basement backups. But here's sort of the issue that we're most focused on is the sewer overflow. So the way the system was designed is that the sewage normally comes from the residential and commercial properties, anywhere there's sewage, into the sewer system, and that's enough. There's enough capacity at the treatment plant to handle that volume in dry weather. But when it rains, the storm water adds to that in those combined sewers, and they overflow. And you can see this, these slides come from St. Louis. You can see the arch. So we're not the only city with this issue. They just happen to have a nice nice graphic depiction of it. But this is the issue that we've been trying to deal with for many years. So why green infrastructure? So green infrastructure is the idea of mimicking nature by absorbing the rainwater, or at least managing it for a while until that storm has passed and there's more capacity in the system. So the idea of letting it soak into the ground, you can have all kinds of technology to do that, but the benefits, you're using plants, you're using trees, and so that's going to have other benefits like raising property values. It's going to beautify your neighborhood. Those trees and those plants will improve the air quality. There are jobs associated with installing and maintaining those green infrastructure project sites. And so that's why we are talking about this. That's why we want to do this wherever we can to manage stormwater, as opposed to building pipes and tunnels and that sort of thing, which we may also need to do in order to reach the water quality standards that we're trying to get to. So these are just some examples. A rain garden, it's basically a depression in the ground. It's like a bowl. And so that allows water to stay there for a while, just long enough to infiltrate into the ground. Whereas if it's a slope or not a bowl, then it's just going to run off into the sewer system. Even your lawn can be pretty compacted and not have that absorptive capacity. Permeable pavement allows water to soak through. You can store it underneath until you can slowly trickle it back into the system or infiltrate into the ground. Street trees are a great resource. You can design a tree pit in such a way that it accommodates a lot more stormwater than a typical street pit, so that's an opportunity. Cisterns are just a way to capture rain. So like a rain barrel is a small version, a cistern is a big version, same concept. So you can reuse that water when it's dry again. And a rooftop garden or a green roof is another opportunity. Wetlands can be used to treat stormwater, and you can put trees in your backyard. You can have a planter box. So you can get creative. These are opportunities to combine landscape and infrastructure, and there's a lot of ways of doing that. So what's the reason why we started talking about this? So the Department of Environmental Protection, the County Health Department, required PWSA to deal with this issue, and the city. So PWSA and the city are joint parties to this consent order and agreement coming from these regulators. Not just Pittsburgh, but all the municipalities in the region had to address this issue. So we were required to submit a wet weather feasibility study, which we did in 2013. And while all the municipalities who were doing that had a gray plan, basically tunnels, storage tanks, then we also saw at PWSA that there was an opportunity to test out green infrastructure and see how much stormwater it could manage and how much of an impact it could make on the issue. So we worked that into our wet weather feasibility study as an adaptive management plan. So we're going to try out green infrastructure, and we're going to see how much it can do. We're going to measure it. We're going to monitor it. So this is sort of the gray plan. It's kind of hard to read, but it's tunnels, it's storage tanks. It's part of a regional solution, but so in order to build from that and get to a green strategy, we had some planning workshops with green experts in the region, because PWSA until that time did not really have the capacity or the knowledge about green infrastructure and what would be possible. So what came out of that was this recommendation that PWSA needed to take the lead on, or someone needed to take the lead, and it seemed like PWSA was the right fit on exploring green infrastructure, and through building partnerships, through education, and that green infrastructure can serve purposes beyond just stormwater management, such as economic development, environmental enhancement, community engagement, etc. So what are we doing now? We are now involved in a study that will tell us where in the city are the most cost-effective places to put green infrastructure. So we're using a lot of technology to do that. We're using modeling software that tells us where the raindrops fall, and we're also focusing on priority sewer sheds. So we have focused on the ones that have the most sewer overflow, or also some of them are actually the smaller ones where we think we might be able to remove the need for a gray solution. We're also looking at stream daylighting, because sometimes streams end up in the sewer system and then we have to treat that water. Why should we have to treat a stream? That kind of thing. So we want to integrate that with urban planning. And here's an example of what another city has done. This is Portland, Oregon. This is a stormwater management infrastructure site, but it happens to be an amenity for some of the nicest places to live in Portland. So this is the kind of thing that we are looking at. This is the kind of strategy that we may be able to implement in the coming years. Another thing that we're doing is working with neighboring municipalities, because water droplets don't care whether you are in Pittsburgh or Dormont. Like, that doesn't matter to them. So we have picked the Sawmill Run watershed as our demonstration for an integrated watershed management strategy. Now, this is an EPA-approved way to address water quality standards. So there are 12 municipalities in this watershed, and they each have regulations they have to meet in order to have clean water. So it makes sense for us all to work together and figure out what's going to be cost effective for the whole watershed, because that's how the stormwater flows. So we partnered with Economic Development South. They're a community development organization in that part of the county. And Army Corps of Engineers has gotten involved, and we have a lot of momentum there. We're doing water quality sampling in the next month or so. So we're going to have data that will tell us where to go next in that watershed. So that's an exciting project. Another exciting project is a grant program that we recently developed. So we had $250,000, which we awarded to 17 projects throughout the city. And these projects, once they're implemented, will manage somewhere between 3.5 and 4 million gallons of water per year. So we think that's a pretty good impact for our investment. And so those are mini grants that go to community groups and nonprofits, as well as matching grants that are going to property owners who are doing more large-scale, significant stormwater management. And I'd be happy to answer more questions about that. So as we're doing a lot of green infrastructure, we want to be measuring it and making sure that it's having that impact that we expect it to, and so that we can go back to the regulators and say, well, now that we know what impact it's going to have, we can use that to modify our plan for addressing sewer overflows and meeting water quality standards. So monitoring is a big component of everything that we're doing. And in order to make this work, we have to partner with many of your offices, many city departments, and this is just a few, and also beyond. So that's something that we have been doing a lot of, and we want to keep doing. And then next we have, Nicole's going to tell us a little bit about the Residential Homeowners Assistance Program, which was part of our consent order requirements, and how that fits in.
Hi, I'm the communications manager for the PWSA, and I'm just going to pop in and interrupt for a minute to kind of talk about this program. This got kicked off at the end of March this year. As Katherine was discussing, we had this consent order and agreement, and one of the things we had to manage was some communities, particularly in the southern area of Pittsburgh, about approximately 4,000 are failing a dye test that is required by this consent order. And the dye test means if you're one of these homeowners who fails the dye test, when you go to sell your house, you can't, unless you make this modification, which requires actually separating your stormwater and your sewage. This process, the process you need to go through to separate, can be extremely costly. The boundary between where PWSA takes responsibility and the homeowners is typically about the curb. So this is a homeowner responsibility. So to help mitigate those costs that will be coming to those people who are going to be selling their homes eventually, we partner with Dollar Energy Fund, which is a great nonprofit that helps to provide utility services at a minimal cost to those who are in financial need. And through partnering with the Dollar Energy Fund, we were able to, PWSA invested $200,000, and we are now able to give grants to those who need to partake in the lateral separation and will need funds to assist them in that process. So there's a varying range of financial need, and it could be as low as giving $250, and it can go upwards from there. Each participant has to pay a 5% copay into the project, but then they will get the rest of the funds applied towards their separation. The information, anyone who's interested in the project, that is the Dollar Energy Fund's Customer Service Center. They are the ones that are actually fielding that information, addressing the financial need, and so forth. And if you are concerned that you are in a dye test region, the regions that are failing these dye tests, you can actually check for yourself on our website and pull up a map of your community, and you'll be able to see if you fall into this category. So that is all on the RHAP. I will answer any questions at the end of Katherine's presentation.
So I wanted to share a few pictures of some of the projects that we've been working with that you may be familiar with throughout the city. So one is the Panther Hollow Watershed Project. There are two parts to this project so far. Working in Shenley Park on Beacon Street and in the lawn coming down the hill from there. We worked with the Parks Conservancy, with Alcosan and Public Works to create a meadow. So a meadow with all of its plants is going to absorb more stormwater than a lawn. So it's going to slow down that water as it's coming down the hill. And there are also some devices called level spreaders that will accept the water and spread it out along the hill so it absorbs more efficiently. Another portion of that project is the golf course where, as I mentioned, lawn can be pretty compacted, a golf course lawn especially. So putting berms or bumps in the landscape to slow that water down is what's happening here. And this is going to help downstream where Carnegie Mellon was having some flooding issues when in rainstorms. The idea is to sort of keep that water on the golf course where it falls. In the 15206 zip code, Project 15206 did several projects. One of them is in Negley Run. They have a rain garden at the corner of Negley Run Boulevard and Washington Boulevard. PWSA was involved in supporting that and supporting monitoring in that project. Another project that I don't think has happened yet, this is an Larmer, and the idea is to do these kind of curb bump outs, so curb extensions, so that it's part of the streetscape and absorbing stormwater as well. River Avenue, PWSA was doing a waterline project, and so we took advantage of the fact that there would be a lot of space dug up and thought, well, let's put back some rain gardens, some bioswales, and a porous asphalt parking lot. And we worked closely with Public Works on determining how to do that. And the Friends of the Riverfront has agreed to help maintain the plants that are going to go into that. At our treatment plant, we have tried to demonstrate right in front of our building what this is like. So we had this traffic island with a raised area in the center. It just had one lonely tree. Our crews dug out the middle to make a big depression area like we were talking about. We had our staff come out and do the planting. Everyone really enjoyed getting their fingers dirty. These are folks who normally sit at a computer screen. But this is what it's looking like this month. And so not only is it an improvement in terms of the aesthetics, at least I think so, it's also going to manage the stormwater that falls in this entire long driveway up to this trench drain, coming down in, and then all around where there are curb cuts entering in there. So, it's a really exciting project, I think. So basically, what we're talking about is using stormwater as an asset, rather than trying to send it away as quickly as possible down a pipe. And as you know, we have a lot of wildlife on our rivers from time to time. So, so this is important. We want to make sure that our rivers are usable every day and not polluted. So that's really what this is about. So should I take questions now?
Yeah.
All right.
We're taping, so if you guys have a question, I want to make sure that you guys speak into the mic, if it will come off. Do you have a separate? Oh. I see. Do we have any questions? Okay.
Just a quick question about the dye test. Where do they put the dye? And what do they, I guess, what's the process of that?
So the dye actually, it takes place in your home, and to do the dye test, you need to hire a plumber. So there are tips on our website about how to identify someone who's, a licensed plumber to do that process for you. And then the plumber gets a report, and we process the dye test. You're basically looking for it to go in your home and looking for the remnants of the dye outside, essentially.
Does that make sense? These are in separate sewer areas.
Do they dye like the roof water or like a toilet water?
It's the downspout, from what I
Downspout,
understand.
yeah.
You're looking to make sure that the stormwater goes in the storm pipe and not the sanitary pipe if they're separate. Other questions?
I'm sorry, is all those projects, or like some of those, related to LEED Commission, or how they related generally? Is it like part of this movement, or this is certified as LEED?
LEED, as I understand it, is so LEED is a green building certification process. There are components of the LEED process that include stormwater management, and so this can fit into a LEED project, but this. Yeah, so I think there's no conflict. I don't know what the nature of your question is.
No help of those. I mean, any grants from the lead authorities? It's not related.
It's not directly related. I mean, the idea of building in such a way that you are having a positive rather than negative impact on the environment. I think that's the theme. Like that's the overlap. Definitely, they're aligned in that way. Yeah.
Like a rooftop garden would certainly add to your LEED certification.
It certainly would.
It
definitely would.
It's not administrative.
Yeah, LEED is overseen by the Green Building Council, and we have to address regulations that come from EPA and DEP and the county health department. So different networks, but the same concept.
I have a quick question. I live in Overbrook, so I was very curious to see if there's any plans yet for the Sawmill Run watershed project. Like, is there somewhere online that has sketches, or is it still just very preliminary? Or
Right now, we're in a data gathering phase. We've been meeting with the municipal engineers in the other municipalities in the watershed. And as I mentioned, we're going to start doing water quality testing and then try to identify where those pollutants are coming from so that we can address them at the right source. So until we do that, then we'll only just have a few demonstration projects. But once we have that data, then we'll be able to identify a plan to address water quality in the whole watershed. And that's when we'll sort of start implementing that plan.
Any other questions? We'll take this last one, then we'll move on.
So you're telling me that water comes down the drain, And if it goes into the sanitary sewer with regular sewage, then you fail the dye test.
If you live in an area that has a separate storm and sanitary sewer, then that's correct, yeah.
If it goes on a storm drain, not like a drain in your house.
We're talking about keeping stormwater separate from sewage. That's really all it is.
Yes, and I'm just wondering where, are you saying parts of the city have the sewage line and the storm, the line
Parts of the
off
city
their
do.
roof into two separate lines?
Parts of the city do have that, and if that's the case, then your home should have two laterals. It should have a sewage lateral and a storm lateral, and those should go to the right pipes in the street or wherever the pipe is. So if that's not the case, then that's when it's failed. And you know, many of the homes in the area that have separate sewers are not failing. They are connected to the right pipes, but some of them are not connected to the right pipes. So that is the issue.
I see, okay.
And I have one more question. What areas of the city do you know have separate systems?
So that is something you can look up on our website. So you can check your neighborhood and see which kinds of pipes are there. And if you have specific questions, then you can call
I'm guessing
PWSA.
the majority are still combined.
Yeah, it's about 3/4 of the city is combined. Most of the separated communities are in the southern part of the city, the South Hills.
Thank you so much. We're going to go next to Jason from PWSA, who's going to share with us some of the commercial and larger green infrastructure things that, that's right, that we're doing in the region.
Good afternoon, everyone. My name is Jason Wirick. I'm the Director of Facilities and Sustainability at Phipps Conservatory. Happy to be here. Some of the takeaways, I've got about 15 minutes with you guys. Just kind of understand what Phipps' mission is, how we're trying to manage our stormwater on our campus, and some of the benefits of managing that stormwater in Shenley Park at our campus. So the conservatory was built in 1893. And I was, thinking about this presentation. I was like, what was the issue back in 1893? Like, what are they sitting in a room 100 years ago talking about? Probably not stormwater. Maybe sanitation. Issues with waste. What happened when it rained? There wasn't a lot of ground cover and things like that. It was probably a much harsher environment. Rampant sickness and sanitation was the big issue, right? And then I started to look back. We've combined sewers, and they're combined for a reason, because back then when they were designing the system, there was a lot more waste in regards to transportation. Horses were used for transportation. There was 20 to 30 pounds of horse waste coming out of each horse, and mass transit and transit used horses. So it was a pretty convenient way to get rid of waste back then with sewers and having city inlets. So just thought of that. Again, the conservatory was built in 1893 by Henry Phipps. It was a gift to the city of Pittsburgh. The city of Pittsburgh owns Phipps Conservatory. The city maintained and operated the conservatory until about the late 80s, early 90s. That's when the nonprofit that I work for today signed a lease with the city. So when we first signed a lease to the city, this is what the conservatory looked like. You can see the front entrance there. It was kind of the straight elevation out from the park to the front entrance. This was the Department of Public Works garage on the lower 40 that operated and maintained the Shenley Park at that time. Now Phipps Conservatory, we've been operating the conservatory almost for 25 years now. Henry Phipps built the conservatory for the city of Pittsburgh. Our mission now has kind of evolved. Our mission is to inspire and educate all with the beauty and importance of plants, to advance sustainability and human environmental well-being through action and research, and to celebrate our historic glass houses. When we first took over operations from the city, we started looking at what the Phipps Conservatory of the future wanted to become, and we set up on a master plan. The city was able to allow us to expand the conservatory to that lower site where the former DPW garage was. So this was our three-phase master plan. In 2005, 2006, we finished Phase 1 and 2, which was the Welcome Center, which sits here. It's kind of sunken. Our entrance changed quite a bit. And then Phase 2 was our production greenhouses, our tropical forest, and our special events hall. And again, this was the lower 40, which was planned for our future expansion, which we just completed about 4 years ago, which I'm going to speak a little bit specifically and talk about today. So the Phase 3A was our project, the Center for Sustainable Landscapes. Really the idea of this project embraced the Living Building Challenge, which requires us to keep all of our sanitary waste, all of our sewage waste on site and treated, and also all of our stormwater. So none of the water from this lower 2.5 acre site reaches the pipe to PWSA and down the hill, down into the hollow and further on to Alcosan. So the building was completed at the end of 2012. It's a 24,000 two-story building. It's our administrative offices, our children's programming and education and research. Some of the goals of the project, I mentioned the Living Building Challenge. We were awarded that in 2015, so beginning of this year. And we also achieved LEED, the Sites Initiative, which is kind of LEED for landscapes, also the Will Building Standard, and the facility is a net zero energy facility, so we generate more on site with renewables than the building uses. And we've been able to quantify the amount of stormwater that we've saved that hasn't impacted the city's infrastructure at 3 million gallons a year, based on taking that stormwater, getting it back into the ground, or reusing it in the building. So when we started planning this project, we're looking at the nature of what nature did with stormwater before we started building on it or developing it. Again, water that falls from the sky, some of it gets infiltrated, some of it gets used by the trees and the plants, some of it is settles in ponds and lagoons, and also the plants use it, and a lot of it evaporates, which we're seeing a lot on our campus in our lagoon over the hot couple weeks we had a few weeks back. So again, we're building on this land, and now water's running off of our roofs and we're trying to push it off to different. If we're in the city where there's not a lot of places to infiltrate, so it connects to the city's infrastructure in certain areas where we can leverage the amount of pervious areas. We're trying to push that water and get it back into the ground. So we're trying to achieve stormwater management, trying to keep the water, the surge of storms out of the infrastructure, so we don't have combined sewer overflows. So some of the different elements that help feed the function of stormwater management on our project are, which Katherine talked about earlier, pervious paving. So over our parking spots, we have pervious asphalt. So the asphalt's not really compacted very well, and there's still kind of voids in it, so it can actually find its way back into the ground. We typically have gravel underneath there, so it allows water to kind of settle in and slowly perk into the surface. Around Pittsburgh, we have relatively clay soils, so it's pretty tough soil to kind of perk very well. So we're trying to create that space between kind of the surface and that clay subbase to allow that water to slowly perk into the ground. Some of the other areas or elements that we're using are rain gardens. We talked about rain gardens, bioswales, bioretention areas to allow that water to settle back into the ground. An open water lagoon, we talked about stormwater as an asset. This is a huge asset for us on our new project and our new outdoor gardens. We have an open water stormwater lagoon that's created a nice amenity for our visitors, and it's created a real interpretation of stormwater, and we have fish and turtles and other things living in the gardens now from the stormwater lagoon. And also underground storage, kind of who Phipps is who we are. We need a lot of water. We irrigate. So we're trying to build infrastructure in cisterns and underground storage capacity to use that water for purposes on the campus, primarily for watering the plants. So this is a quick snapshot of what the lower campus looks like today. The building actually sits here, the Center for Sustainable Landscapes. This is the upper campus here. These are some of the old DPW buildings, which we're integrating probably in the next couple of years. But I'm going to try to showcase with a diagram of how water kind of flows onto the site. And so really the first place water falls onto the site, we can actually take water from the tropical forest roof, which is a big glass roof, and it comes through a pipe and actually fills up a cistern, a 1,700 gallon cistern, that the water's stored there, and we can use it for toilet flushing or for irrigation or for service water for the sidewalks and things like that. If this tank overflows, it finds its way into the lagoon. And the lagoon is a wetland with wetland plants, and a lot of the water will be used by the plants, and actually there's an underground perforated pipe that's in the soil medium of the plants, so the water is being pushed there and it kind of bubbles up through the plants. So the plant's roots are helping to clean that water. And again, all the water that falls on the site is perked in back into the ground, or if there's a large rain event, it'll find its way into the lagoon. If the lagoon overflows, it finds its way to a large chamber underground. There's gravel, and then also they're called aqua blocks, which are big kind of plastic things with voids in them, so the water can rush in there, stay there, and then slowly perk back into the ground. We actually have a valve where we can take some of the unlined tank, and again, a lot of the water from the surfaces, like the roadways, find its way into the rain garden. If the rain garden overflows, it finds its way into that unlined chamber underground where we can tap into that water. We've actually built another lined cistern here that taps to the upper campus. And we were fortunate enough to work with PWSA on some funding to link the lower campus to the upper campus, allowing some of this excess stormwater to feed up to the upper campus, where we have another cistern, and that cistern will be used to irrigate the upper campus display areas in our production house. So we're really excited about that project. And again, it's going to take all the rainwater that fell off of this glass roof and keep it out of the city's infrastructure. So we're really excited to reuse that water. So that's kind of the path that stormwater falls on the lower CSL site. This is just a picture of one of the 1,700-gallon cisterns that we talked about. Here it is being installed. This is just a quick schematic of this is the cistern underground, and then it comes into the building into a filtering and disinfection packaged unit, and here's a picture of what that looks like. So it's taking the storm water, it's filtering it, and it's actually disinfecting it with UV lamps, and that's what you see here. So we're treating it to a minimum level, some of the storm water, and that's based on the DEP standards for reuse water. So just a quick graph of the CSL building. We've been in the building for about 3 years. Overall, the usage of the building is pretty interesting to see how much potable water from PWSA, which is drinking water and faucet water, it's about 10% of the building water use in total. The rest of the 90% is for conveying waste around the building. So it's taking toilet water, running it through an on-site system. So it's really interesting to see that on a, if you start, we have a relatively small building, we should start to scale that, thinking up, 10% of the water is just for hand water and drinking. The rest is just moving waste around. So it's kind of interesting to see that and to, that concept on a larger scale, what impact that could have or eliminate the impact downstream into the infrastructure. But again, we reuse about 80,000 gallons of, it would be potable water, but it's reuse water. It's wastewater that we're using for the toilets, but that's specifically on the sanitary side. Yes?
Is there any water testing done, even though the cistern water is not used for drinking?
Sure.
But is there any basic testing though?
Yep. Yeah, we're required by our permit from the DEP to do quarterly testing. So it's looking at things like fecal coliform, biological oxygen demand, the Class B standards for DEP. We do that on the stormwater, but also we're required to do it on the sanitary. We take raw sewage, we treat on site, and then we put it back on the toilets. That's really where the testing comes into play for our sanitary system. Yep. Just another thing to highlight, we talked about some of the green roofs, some of the different elements that we use. We have a green roof on the CSL, which not only helps to hold back storm water and get it back in the ground used by the plants, keeps the storm surge on the roof and not down into the city's infrastructure. We're monitoring this through performance, and I'll highlight those with a few graphs. So this is just what the green roof looked like when it was being built. A waterproof membrane, you can see the insulation going up. This is the drainage board before we put the planting medium down. This is the guys putting the soil medium down, and then we planted the roof afterwards. So a nice amenity. We talked about stormwater elements as being an amenity. This is part of the paid experience to go to Phipps, is to check out some of the plants on the roof and experience some of the views on the lower portion of our campus. And this is what it looked like earlier this summer. Kind of blends in with the landscape. All right. This is the stormwater lagoon that we talked about. When that cistern overflows, it finds its way into this lagoon. And again, we've created an amenity for the garden and also an interpretive aspect. So the fountain runs off a skimmer, so the lagoon has to be at a certain level. And we've had a lot of, before this kind of cold snap, we had a really long dry spell, right? Not a lot of rain. The level of the lagoon, it was very warm. A lot of evapotranspiration, and the air, the water was kind of burning off, so the lagoon settled down, and the fountain turned off. And a lot of people are asking, why is the fountain off? You know, because we haven't had a lot of rain, and this is a stormwater lagoon. So it's a really great way to kind of interpret some of these different things in our landscape, you know, back to people and how they think about water and some of the issues that we have with stormwater in the region. This is a picture of those aqua blocks that I talked about, that underground chamber that holds the water and allows it to perk in. This will give you a little more an idea of scale. There's a couple people standing here working, installing those blocks. Again, half of this is unlined and half of this is lined. This is the lined portion that's tied to our upper campus. This is the unlined portion that allows the water to perk back into the ground there. Again, this is just another side of, I was up on the roof taking a picture. This is down on the ground. This is one of the rain gardens. We talked about the depressions, and also where the inlet is. You can see the inlet's kind of up high in elevation, and the curb cuts. So when it rains, the water actually goes in, similar to PWSA's project in front of their office. This is kind of scaled up, the two rain gardens here, and then this rain garden sits over top of that unlined chamber under the ground, so it allows the water to perk in. Here's some different pervious asphalt that's along with the system. And again, that underground chamber kind of sat here and here. We showed that picture of them building it. That's what it looked like this winter. It's working well. We've been in the building for about 3 years now, operating the different systems. This is the stormwater lagoon. This is what it looked like over the winter. Now I'm going to highlight a little bit about some of the monitoring that we're doing of these different elements. So specifically the green roof monitoring stations and also the rain garden monitoring stations, understanding the performance of these elements, understanding the mechanisms of where water is moving around in the soil and kind of how they're working. This is the green roof, which we're actually monitoring. The devices kind of sit here. And so what we're doing is we have a rain gauge, so we can see when it's raining, and we can understand how the system is kind of interacting over time in regards to the green roof. So we have a weather station. We understand when it's raining. We also use different sensors that have moisture content readings that go in different layers of the green roof, so we can see how quickly water is moving through the green roof, how much water, what the quality of the water is at certain levels. So this is some of the cellular monitoring that we do. This is a profile of that green roof system. So here's the surface up here. We have a rain gauge. We have our temperature and humidity sensor. We can understand where the water is, the layers, the moisture content in the soil. We also have a temperature gauge on the top of the insulation, the bottom of the insulation, and also inside the building as well, trying to understand the insulation factors of the green roof. Also, we have a lysimeter. So this is just a kind of a mock-up of a 2x2 square foot section of the green roof. So we're just building up in this little box the same profile as a green roof, so water can perk through there. And then once it hits the bottom of this tank, it actually comes out of a pipe, and then it spins another rain gauge. So we can see when water has gone all the way through the green roof system. And I'll highlight that on some of these graphs later. This is after we buried the lysimeter. So what we've been able to do is show the amount of runoff reduction from the green roof. So when it rains a lot of the water is held onto the green roof, and it's used by the plants, or it's evapotranspirated quickly. So it's holding back the water from the storm surges that hits our combined sewers, and it's also being used for the plants. So we've been able to show an 87% kind of annualized reduction over this time period. So it's pretty good. It's holding back a lot of that water. Again, and on the CSL project, we have goals of no water touching the city's infrastructure. So when this overflows, it just finds its way into the lagoon, building those different elements along the way. So this breaks down kind of different storm events. So the big blue line is actually when it's raining, how much it rained in millimeters. And then the little red dot is when that lysimeter rain gauge down lower, the amount of water that went through the system. So you can see the amount of reduction that's done. So we kind of focus in on a typical storm event. It's raining, it stopped, and then we can sense the amount of water going through the green roof system and when this bucket is being tipped. So that's how we come up with the reduction per storm event. And then also even during Hurricane Sandy, we showed the amount of reduction, 76% stormwater reduction during this this storm event. So it's pretty interesting to build this data and to showcase to different policymakers and people that are making big decisions with our infrastructure on these different projects around the city. So we're excited to be a project that's being monitored. Another project is the green roof, or a rain garden. So this is just a typical rain garden, a depression in the soil. This is kind of the profile of one of those. We talked about in Pittsburgh, we have a lot of clay soil, so it's pretty tough to infiltrate water into those. So the way that this was designed, there's a gravel layer, which creates a lot of voids, and then also more of a sandy soil that's not compacted, so allows the water to kind of hold into that soil. You can see the overflow inlet here, which is tied to the backup system. And again, we have level sensors and moisture sensors in different areas of the rain garden. This is John Buck, who's kind of a green infrastructure champion, I like to call him, setting up some of the monitoring from civil and environmental consultants. So we actually installed this stuff after the green roof was put together. You can see some of the different sensors going in, and it all ties to the cellular kind of readout that downloads the data periodically. So these are some of the outputs from the monitoring. It really shows how fast it took water to kind of come through the rain garden. 10 inches per hour, this is kind of that sandy layer, and then this is more of the clay layer down lower, and so it took a lot longer to get that water back into that clay soil than it was the sandy soil. And what we're starting to see also is, depending on the design of the rain garden, we talked about, there's multiple factors and how well it's performing, how much stormwater, but we're trying to understand what types of head pressures exist in between those depths to allow this to perk quicker. Yeah, you want it as big as you can get it, but you probably can't dig down 10 feet. So there's kind of a happy medium in what types of soils are used, how big that gravel layer is. So we're really honing in on that. Another thing for us is we want to capture rainwater for use on the upper campus for irrigation, but we're trying to capture water that's coming off of pavement. In the wintertime, we're de-icing. We got to get rid of the ice, make sure everybody's safe, but that does impact some of the groundwater that we're trying to capture, and so we're monitoring some of those levels. So, if we are irrigating in the winter in the future and we're trying to capture this water, when's the best time to capture that? When can we use it? When can't we? So kind of quick in conclusion, for us, the Center for Sustainable Landscapes, we were able to show that there was no sanitary or stormwater that got into the city's infrastructure. That was kind of the goal of the project. But also this data helps to prove that even in our clay, soil conditions, that infiltrating is an option depending on the type of design of the green infrastructure. And so we're really advocates for solutions to a lot of the combined sewer overflows. We feel like those are really upstream. They can be handled kind of at the localized level, whether it's residential or on a commercial scale. So again, the conservatory, we lease from the city. We hope to, we see ourselves as stewards of this place, and we want to build in a lot of these kind of redundant, resilient systems. So down the road, we can rely a lot on the rain that falls on our campus to capture that and reuse it, and just really. This place has been here for 100 years. We're trying to invest in systems and things that it will be here for the next generation.
Good afternoon. My name is Nancy Martin. I work for the Pennsylvania Resources Council. I want to thank Afton for inviting me here today, and I've been really impressed with the presentations I've heard. We'll take a look at what we as homeowners can do. I think some of the things that I was planning to cover have been covered. We'll kind of fly through some of my photos here and pictures of some of the images that I have. Pennsylvania Resources Council, for those of you who are unaware, is one of the oldest environmental nonprofits in the Commonwealth of Pennsylvania. We were founded in 1939 as the Pennsylvania Roadside Council, and today we are the Pennsylvania Resources Council. Our mascot is the litter bug, and we have a lot of different projects going on. But basically, our mission revolves around solid waste reduction, but we also do some watershed work. So we're Zero Waste Pittsburgh. I have handouts over there. We do the hard to recycle collections, the household hazardous waste collections, and all of these things ultimately tie in with water quality. Some of the adult community workshops, folks have been asking me about the rain barrel workshops. We do composting workshops, backyard composting, vermicomposting, that's indoor with worms, the rain barrel watershed awareness workshop, and Healthy Body, Healthy Home, Healthy Planet, which also ties in very closely with water quality. So we've talked a lot today about quantity, but quality is a big issue too with stormwater. All of the different toxins, human waste, toxins, all endocrine disruptors, lots of different things, pet waste going down the drain, and ultimately are part of these combined sewer overflow and part of the issue. This is just a picture of all of the water in the entire world. If put into a little sphere is just that large. So it's a very precious resource, and as most of you probably know, we never get new water. The water that's on the planet today is the same water that's always been here. We never get new water. Of course, the water cycle keeps purifying that, and hopefully infiltration is part of that process. Then in this photo, we see all of the Earth's water, all of the Earth's fresh water, and this little tiny dot is water in lakes and rivers. So we're extremely fortunate in this area to have a lot of water and rivers. Not the case elsewhere. Oftentimes we talk about watersheds, but there are always some people who are like, just what exactly is a watershed? So a watershed is an area of land that all drains into the same body of water. Watersheds are nested. Little ones inside bigger ones, inside bigger ones. I live in the Lip Run watershed. That means all of the water from my yard drains down into a little tiny creek called Lip Run. That's the collection site for my area of land, my watershed. But Lip drains into Gertie's Run, so I also live in the Gertie's Run watershed, which drains into the Allegheny River. I also live in the Allegheny River watershed, etc., etc. So an area of land that all drains into the same body of water. What's important about that is the way that we live on the land affects the quality of water in our rivers and streams, even if we don't live right on a river or stream. Watersheds are bowls, the collection sites down in the bottom of the bowl, like you can see right here. The top of the hills that separate one watershed from the next one over. Watersheds, I neglected to say, are separated from one another by elevation. So all of the water that falls between the tops of these hills and the tops of these hills drains down into the bottom of the bowl, and there you have a watershed. Everything water passes over, it wants to pick it up and carry it along, dumping it right into our waterways. So some of the big watersheds in this area are the Allegheny River watershed, the Monongahela River watershed. There's Pittsburgh up the top, unusual because that river flows north. And then they, of course, form the Ohio. This yellow area is the Ohio River watershed. So there you have the Ohio River, the blue thing in the bottom of the bowl, and all of that land and everything happening on it draining into the Ohio River, which is inside the Mississippi River watershed, which drains, a little over half of the United States, even extending into a little bit of Canada and Idaho. And then, of course, the Gulf of Mexico watershed. So those are the watersheds that we in this region are in. Human impact on the watershed, what we're here to talk about today. We have two main types of water pollution. I'm going to talk fast because I have a lot of pictures. I like pictures and a lot of information in a little bit of time to share it. But anyhow, two types of water pollution, point source and non-point source pollution. This is point source. CSOs, combined sewer overflow, is point source pollution. One of the reasons why we're in violation of the Clean Water Act and are mandated to get our sewage out of the rivers. So basically it means you can point to the source. It's easy to identify the source in point source pollution. It's not as big a problem as it once was because of the passage of the Clean Water Act in 1972. We don't have, hopefully, factories just dumping pollution straight into the river. The biggest water pollution problem facing North America today is the opposite, non-point source pollution. That means it's coming from all over the place. It's hard to identify a single source. You can't do it. So it's coming from homes, schools, yards, businesses, mining, you name it. It's a little from here, a little from there, but it adds up to a big mess once it hits our rivers and streams. So now about our own residential sites. What I like to see is on-site absorption, and we've talked about that today. Any rain that falls or snow that melts on our yards, if we have the space, should be absorbed on site. We don't want to see it going across impervious pavement, and of course rooftops are impervious as well. It becomes polluted runoff and then pollutes our rivers and streams. So What we're striving for is on-site absorption, having the water that falls on our property be absorbed on-site. And there are a number of ways, as we've talked about, to capture that and have it be absorbed on-site and not become part of this, too much water going to Alcosan, basically, and causing CSOs. So in our landscape, water can be stored in tanks and cisterns, ponds, pools, rain barrels, rain gardens, swales, and vernal pools. So a lot of these things we've already talked about a little bit today. On-site absorption or infiltration, percolation is awesome because with filtration, we have reduced flooding, we have a reduction in erosion, reduction in non-point source pollution, we have increased groundwater recharge, which is great, a reduction in combined sewer overflow, and simply healthier waterways. But improperly managed stormwater causes flooding, water quality degradation, stream channel erosion, reduced groundwater recharge, loss of aquatic species, and combined sewer overflow. So in these two images we see over on the left, in a natural area, we have about 50% of the water going down into the soil so that it can work its way slowly and gently downhill to the nearest body of water and being filtered on the way as water passes through the roots of vegetation, through sand, soil, and rock in the soil. It gets filtered. It's much, much cleaner by the time it hits a body of water if it passes underground. Or we have runoff, just going across pavement and rooftops, washing them, picking up lots of contaminants and dumping them in our waterways. So just another picture of what this combined sewer thing looks like. Basically, like we said earlier, we've got our sewage and our stormwater going into the same pipe. And we also talked about how much of this is actually happening in this area. Every year in southwestern Pennsylvania, enough raw sewage is released into our groundwater to fill Heinz Field about 100 times. And we also mentioned earlier that it only takes 1/10 of an inch of rain in the rainy season to cause combined sewer overflow in our areas. This is simply a picture of impervious surface carrying lots of pollutants. This is a picture of 9 Mile Run before the Army Corps of Engineers came in and did the remediation work. So in the upper left, on a dry day, you have very little water in a stream because there's so much impervious surface that, there's just very little groundwater. But about 10 minutes after it starts to rain, it would look like the bottom right. Just sounds like a freight train's coming through that pipe and the water just comes bursting out, causing all of those related problems. So filter strips, vegetation strips, swales, bioswales, lots of different names for these, is one solution. In parking lots, instead of directing all of that water into a storm drain to go out to a river or to Alcosan, it simply is directed into a vegetated area where it goes into the ground and works its way slowly and gently out to the nearest body of water. And these are some ways we can do that even in our yard with our driveway, for example. So these are just some different examples of permeable pavement. Anything from something very fancy to my home, just a gravel driveway, an old school style gravel driveway. And more impervious pavement, just picking up lots of different types of pollutants. So in our own lives, in our own residences, these are some of the aspects of our lives where we have a direct impact on water quality. Lawn and garden care, pet care, car care, whether we recycle or not, litter, lawn and garden care, farming and the type of farming we support by the types of foods that we buy, the use and disposal of pharmaceuticals, and definitely the use and disposal of household chemicals and personal care products. So at PRC, we advocate going green and clean, using green cleaning supplies, green personal care supplies. A lot of these are very easy to make. We do workshops on these, so I'm just mentioning these things. If you want to know more, I've got information over there about our other workshops. But anyhow, you can make them, you can buy them ready-made. Antibacterials are a big problem in our waterways. They contain a pesticide. Scientists are telling us there's no reason to use these. Regular old-fashioned Castile soap works just as well, it's just as effective at killing germs. But these antibacterials can foster the growth of bacterial resistance, and they're very harmful to aquatic creatures. No reason to use them. In fact, in Minnesota, they're banned. They're fat-soluble, meaning they build up in our fatty tissues, so they biomagnify. Just to quickly mention, they're now finding lots of synthetic fibers in fish in the oceans, and they're attributing that to washing clothes made out of synthetic fibers. And this is kind of fairly new information, microplastic pollution. Lawn and garden care, obviously, what you put on your lawn is going to wash off, go down the drain. It ends up in our rivers and streams, so chemical fertilizers and pesticides. They say that the average American lawn uses up to 10 times more chemical pesticides per acre than farmers use on crops. So we want to try to stay away from the chemical fertilizers and pesticides because whatever you put on your lawn eventually hits our waterways. Lots of reasons not to use pesticides. They're harmful to children, they're harmful to fetuses and infants. According to the EPA, 300 million pounds of cancer-causing pesticides are used in the U.S. per year, and there are special problems for pets. They're running around in the grass, lying on the lawn. Farmers, of course, and farm workers, and children who are outside playing and breathing more heavily, more breaths per minute than adults. This is just one pesticide, atrazine, that's been studied for, at least 30 years now. It's an endocrine disruptor. Lots of things are endocrine disruptors, and they're pretty awful. They get into the waterways. They affect aquatic species. There's been a study done across the United States on atrazine. 95% of the frogs tested, male frogs tested in areas where atrazine is used, the male frogs were full of eggs. Their testes were full of eggs. A similar study was done in the Three Rivers area, and 87% of the male fish were their testes were full of eggs. So endocrine disruptors upset our hormonal system. They're found in a lot of cleaning products and personal care products, especially things with fragrances.
So the organic cleaning products are the way to go, you're saying?
Yeah, that's what I'm saying. Yep. And of course, you have to watch out on labels and read the labels because there's no law governing that. So it can say safe, it can say natural, it can say green, eco-friendly. All of that means zero. You've really got to look at the label, make sure it is certified by a third party. It'll be either USDA certified, but you can also read the label and see what's in it. So anyhow, these things are very harmful to our surface and groundwater, our drinking water ultimately, aquatic life, and other aquatic species. So what we recommend is the natural non-toxic pesticides and fertilizers. You should never use a pesticide if it looks like rain because then they're washing off full strength. We recommend using mulch in a garden to keep the moisture in and the weeds out, controlling erosion by planting a cover crop, native plants, of course, always, and composting grass clippings and leaves. We never want to hose those down the street or the sidewalk where they go into the storm system, into our waterways, and that creates another whole set of problems. This is just one natural herbicide, corn gluten meal. It's a pre-emergent. You use it early in the spring, but works quite well. It's available at almost all lawn and garden centers nowadays. Just remember, when you're fertilizing the lawn, you're not just fertilizing the lawn, you're fertilizing the river as well. This is a great organization, pesticide.org. They've got solutions to all of your pest problems, anything from the tiniest little gnat to full-blown voles, moles, raccoons. You can visit their website if you do want to look for a safe pesticide for some reason. Okay, so farming and the types of food that we support. If we're supporting factory farming, then we're supporting the use of a lot of chemical fertilizers, pesticides. There's a lot of manure going into the water from these places. The animals, there are so many shoved into a small area that they're typically on lots of medications, antibiotics. All of that's in their manure and washing into the waterways as well. So we like to support our local farmers and also organic farming. Car care is a big one as well. And let's take a look at some of that. We want to make sure we clean up our brake fluid, our oil, our grease, and our antifreeze immediately. We don't want to hose that away. We want to clean it up with something absorbent. We want to pull our car onto a grass or gravelly area so that the water has a chance to infiltrate and get filtered as it's working its way to the nearest waterway instead of just down the street into the storm drain. 1 quart of motor oil can pollute 250,000 gallons of water, so we like to recommend that people take their motor oil, their antifreeze, all of that stuff somewhere to be recycled, and we collect that at our household hazardous waste collections. And again, the dates, there might even be one tomorrow at Heinz Field, if I'm remembering correctly, but it's over there on a postcard. I don't work at those, so I'm pretty sure it's August 29th at Heinz Field. So, okay. Recycling a gallon of oil saves lots of energy, and but can cause an awful lot of pollution, and lots of it is disposed of improperly. We want to take our batteries, our oil filters in for recycling as well. And basically, keep your eye on your car, monitor it. If you're dripping oil and gas, we need to deal with that. And remember, when you're washing your car in the driveway, you're not just washing your car in the driveway. Pet waste is a biggie. They're finding lots of pet waste in our rivers and streams. We all wish we had the dog there in the top image, but I don't think any of us do. So we can compost pet waste. We don't want to use that on edibles, but it is easily composted. So we never want to just let it lie, because that washes ultimately into our waterways. Lots of dogs in the United States, lots of feces. And so much for that. Just remember, when your dog's going on the lawn, it doesn't just go on the lawn. We need to deal with this stuff. Other things to take into consider are our solid waste reduction. We can compost. Compost is also great for the environment and reduces water pollution, because it's reducing the amount of material we're sending to our landfills, as does recycling. If everyone were to recycle everything that one can recycle and compost everything that one can compost, we could reduce the amount of material we're sending to our landfills by 75%. And the size of a typical landfill is 100 to 200 football fields. I visited one in Monroeville. It's the size of about 400 football fields. So they're quite large. Leachate is the toxic liquid that forms in the bottom of them. There are precautions taken, but we don't know how long these rubber liners that are about this thick are really going to last. So we want to try to keep as much waste as possible out of the landfill by recycling and composting. And it also saves energy, saves water, on and on and on. There's just, it's kind of a win-win-win-win recycling. This is the one of the highest hills in Ohio. It's Mount Rumpke. That's a landfill. There's little you can do with a landfill when it's all said and done. It's a big hill, and things don't really decompose in a landfill. The conditions necessary for decomposition to take place are not present in a landfill, so stuff just kind of sits there. And of course, by recycling and composting, we're reducing the need to devastate the earth through the extraction industries, mining. Household hazardous waste, I've mentioned. These are all of the things we also want to keep out of the waterways. And this is just what some of them are. And like I said, we'll be collecting those Saturday, I think, at Heinz Field. Household hazardous waste kills organisms in our lakes and rivers, destroys wildlife, causes reproductive problems in wildlife, and limits the overall ability of an ecosystem to survive. So what can we do? We can buy only what we need of these products, try to find less toxic alternatives, give unused portions away to people so they don't have to go out and buy it, bring your stuff to one of our household chemical collections, and basically take responsibility for what we buy. And of course, we never want to pour it down the drain, put it in the trash, or dump it on the ground. Pharmaceuticals, there was a study done across the United States. I think there were about 25 cities involved, and in Philadelphia, they found 56 drugs in the drinking water, the tap water. This wasn't water testing in a river or a stream, it was actually tap water. So we want to try to dispose of our drugs properly. We used to think that meant flushing it down the toilet, but now we know it does not mean flushing it down the toilet. You can return them to pharmacies, you can crush them up, mix them with things like coffee grounds, and throw them away. But don't flush. And of course, litter, I don't think anyone in here would be a litter bug, but actually most litter is accidental. It's everywhere, all of our rivers and streams. It ends up in our oceans, where we have these 5 garbage patches now that have been discovered in the oceans. Our garbage goes up to the North Atlantic garbage patch. That's a picture of it. The Pacific garbage patch is supposed to be anywhere from the size of Texas to the size of North America, and about 30 feet deep. The litter, by the time it gets there, is so small from the sand and the sun and the salt that they can't really even filter it out. So it's just a giant mess, but it is affecting. This is an albatross. There's an island out in the Pacific where they're finding lots of dead birds, and their stomachs are full of plastic. So healthy water means we need to have healthy, earth-friendly lawns and gardens, use green cleaning and green personal care products, no littering. We need to recycle, compost, pay attention to our vehicles, pay attention to our pet waste and clean it up and dispose of it properly. Sign up for green energy. That's a great idea, and there's lots of opportunity for that in this area now. Think about things when you're shopping, green consumerism, and think about that on-site absorption that we've been talking about. And this is one of the ways to do it. A lot of people here have asked me about our rain barrel workshops. So that's where we used to teach you how to make a rain barrel. This year we're starting to just give you a very nice ready-made rain barrel. If you come to the workshop, you can go to our website, prc.org, to see when our workshops are. I'm just setting up the fall schedule now. Some of them are on there, not all of them are. But rain barrels recharge the ground naturally. They reduce water pollution because we are reducing stormwater runoff. Same thing, they reduce flooding. They're very inexpensive to make, build, and easy to install. You're conserving water, reducing the chlorine you're using on your lawn and garden, saving money, reducing CSOs, decreasing your impact on the local waterways, and just being a good steward of the local watershed. Over there you see the rain barrel we used to make up until now, and this is the rain barrel that you now get when you come to our workshops. Both are 55-gallon drums, or 55-gallon capacity. One's a 55-gallon drum. They're super simple to make, but it turns out a lot of people didn't like my 55-gallon drum and the bright blue and the bright green, because that's all I could get. They have to be food grade. And so now we've got this nice barrel, and it's 50% recycled content. Few things about rain barrels. It's not a toy, so you have to think about things like electrocution. When you're hooking it up, you don't want to have it near any kind of cables or conduits. You don't want children playing around it. You don't want anyone, obviously, to take off the top, fall in, and drown. You have to be paying attention. Tipping hazard, if these things fall over, they weigh a lot. A gallon of water weighs 8.34 pounds, so times 55 is, I don't know, 400 and some pounds. So you have to pay attention when you're installing these that they're very level and very secure. So you want to make sure the ground's super level. Typically you're going to elevate this because you're using gravity to get the pressure going. So you want to have a level, make sure as you're piling up your cement blocks, maybe too high, that everything's very stable and very level. This isn't water that you can drink. You don't want to give it to your dog either. It's not for anything other than lawn and garden and groundwater recharge. You know, it's fine to just catch it and release it and let it get back into the ground, even if you don't want to use it on plants. Again, we need to make sure it's level, and we want to elevate it because we're using gravity to get that pressure going. They also have these things called diverters that you can find online. That means once the barrel's full, you can make the water go elsewhere, either into an absorbent area on site or back into the system, which is okay if you live in a place with a separate system for stormwater and sewage. But if you live in an area with a combined system, it really doesn't make much sense to put it back into the system. So it's best to run your overflow off into an absorbent area. You can connect more than one together to double or triple your capacity. Very simple to do. This is the calculation to figure out how much water you can harvest from your roof. Basically, you're going to take the square footage of the house. Doesn't have anything to do with the size of the roof, the pitch of the roof, just what the roof's covering. So you take the square footage of the house times 0.6 times 40 inches, which I thought was the annual rainfall, but then I saw on another slide it's like 36 to 38, so it's something. But anyhow, that's the calculation, and you can see that a house with just a 1,000 square foot base would provide 24,000 gallons a year. So if a whole neighborhood did this, we're talking about getting millions of gallons of water out of the combined sewer system. And some pictures of barrels. So store-bought barrels, homemade barrels, that's a Delalo olive barrel on the bottom left. And you can paint your barrels too. So you can get as creative as can be. Wooden barrels. There's some gorgeous ones out there. You can stencil them. It's a Girl Scout project just waiting to happen. This is a type of paint, Krylon Fusion paint, that's good for plastics. You want to wash it down with a solution of half vinegar, half water, sand it lightly, take a cloth and wipe all of that dust off before you paint it. But I think it would be a very cool project. At my workshops, they're only an hour and a half long, so we couldn't really get into this, but someone could. Just some more pictures because I just think that people have done some great jobs. And if you don't have a downspout to hook up to, people have thought of this idea, because if you just set a barrel out there and we get a half an inch of rain, you're going to have a half of an inch of rain in the bottom of the barrel. But if you can harvest it somehow, fashioning one of these rain saucers And I think that's from a website called aquabarrel.com. They have all kinds of cool ideas on that website. So you don't want to use your water from a rain barrel to water a vegetable garden unless you have the right kind of roof. But if you've got wooden shingles or shakes that have been treated with chemicals to resist rotting and moss growth, a zinc anti-moss strip, copper roof or copper gutters, asphalt shingles that are zinc embedded, all of that renders your water not suitable for an edible garden. So that is something that I hate to say, but, feel like I have to. But it's still great to do it, and, on-site absorption, once again, just recharging the groundwater is extremely valuable. Some other options, all of these have already been mentioned, but we'll fly through the residential application of these. Rain gardens also help to reduce flooding by absorbing rainwater and stormwater runoff. Vegetation can remove up to 99% of toxins from water, so they're great at cleaning water. You want to really have it 10 or 20 feet from a foundation, so that looks a little shady to me. The Rain Garden Alliance is right here in Pittsburgh, the Three Rivers Rain Garden Alliance. So they've got a website with all kinds of information about how to install a rain garden, how to build one. But basically, like everyone has said, there's a depression. If it's in your yard, it could be 18 to 2 feet deep. You fill it up with absorbent materials, sand, straw, compost, plant natives in it, and you've got yourself a rain garden. You just direct your roof water there. Or what I like to do is have the overflow from the rain barrel go into the rain garden. Just some ideas, different ways people have done it, but yeah, they're really great. And this is up in Erie at City Hall. There was a big parking lot, and all that water full of pollution from the cars was going straight into the lake. So some kids came along from the Pennsylvania Lake Erie Watershed Association Auxiliary, it's like the junior auxiliary, and they put this rain garden in on the bottom right. So now all of the water from City Hall goes into the rain garden in the parking lot. So therefore, goes into the ground, on-site absorption, and gets filtered as it works its way to the lake. This is putting one in a yard, so you can see the water just comes from the house, down the hill, out the pipe. Then we covered that pipe with rock so it could disperse more evenly, and planted native plants. All there is to it. It's not difficult. And about 20% the size of the area draining into it, roughly. We want, of course, use natives because they're the easiest to take care of in this area. They are best in our climate, need minimal care, attract our local butterfly and bird populations, and just work best. We've also talked about swales, and that's kind of like a ditch, a trench. It could be shallow, it could be deep. You put it in on contour with the land, and it catches water as it's running down a slope. And you tend to then find vegetation because, of course, there's a lot of water. Trees, we've also mentioned planting trees in your yard absorb tons and tons of water. So that's another thing to think about. One tree can absorb hundreds of gallons of water during a rainfall. In the city of Pittsburgh, they have a street tree inventory. We've got 33,000 street trees intercepting 15 million gallons of stormwater a year, about 60 gallons per tree. But as these trees grow, they're going to be using more water, intercepting more. And also the leaves on trees intercept rain before it hits the ground, which helps to prevent evaporation and just erosion is what I'm trying to say. And of course the roots absorb lots of water and prevent sediment and runoff. And if you don't have any place to plant trees, and this has already been mentioned as well, planters. And we can grow things in plants, and those will also absorb a lot of water in our landscape. This is a riparian buffer zone if you happen to have a creek or a stream nearby. We did this project in the upper left on Peters Creek with some children from middle school in that area. They planted hundreds of trees and native shrubs along along Peters Creek. And above ground cisterns have also been mentioned. This happens to be out at my house. That's an 1,150 gallon above ground cistern. And the overflow from that goes into the rain garden. So, any questions? Great. All right, thank you.
All right.
So thank you so much for joining us today. I just wanted to give a round of applause for all of our presenters. They were awesome. If you have any one-on-one questions, they'll be able to linger for a few minutes afterwards. And just one more thing I wanted to let you guys know about was our next workshop is going to be on air quality. That's on September 26th, same time, same place. And then also we have a homeowner's guide to downspout disconnect, which is going to be up on the city's website, which is pittsburghpa.gov/sustainability. So if you're wondering about how to disconnect your downspout, there is a user's guide for that, and that will be available. Oh, it's on the PWSA's website as well. And if you can't remember everything that you guys learned today, don't worry. It's going to be on the cable channel, and it'll also be on our city's YouTube channel as well. Thank you so much.